Hello everyone. Welcome to our today's webinar, How to Optimize Energy Consumption in Industrial Systems. It's really my pleasure to welcome you to today's event that we prepared together with our guest speaker. I will now say something more about us. So today's speakers are myself, of course, my colleague Dan from our office in Slovenia, and our very welcome guest, Tomasz from Poland, from company Elsta, which will share today's reference. Today's agenda will include brief introduction of our company profiles. Then we will share some details regarding Zenon software and renewables supported with battery energy storage systems. And the most important today is our use case today from Elsta company, which will show the case study with BESS and Solar PV in company Elemental from Poland. There will be a Q&A session at the end, so you please post your questions in a Q&A or in the chat, so we will see everything and try to answer the questions which will be not answered during the webinar. We will answer afterwards, or you can contact us in any time. So let's start with brief introduction. Zawiercie exists more than 20 years now. We are present in Balkan region, so in 8 countries, from Slovenia to North Macedonia. We have 3 offices in Ljubljana, Zagreb, and Belgrade, and we bring to our market innovative software and hardware solutions from world-leading manufacturers such as Data, which is today's topic of the webinar with Zenon software. We are present in many areas such as energy, infrastructure, food and beverage, pharmaceutical, automotive, and other cross-industries. Data exists almost 40 years, based in Austria, in Salzburg. They are developing Zenon software. They're doing also sales and technical support together with us in our local market, and also trainings. They have more than 400 employees, more than 5,000 successful customers, and more than 300,000 installed Zenon systems worldwide. Zenon can cover many industries. As I mentioned at the beginning, Zenon can cover energy and infrastructure, which is our today's main topic, but also a lot of references from pharmaceutical, food and beverage, and automotive sectors. Bringing up the energy topic today, we can cover most of the energy areas such as substations, different substations, grid connections, renewables, starting with solar PVs, wind powers, battery storage systems, and also in commercial sector, there are e-mobility, commercial building, industrial consumers, traction power for the public transport, also hydropower plants, conventional generation plants, and etc. But we will dive into more details further. So I will now let Dan explain more details about Zenon software and renewables with support for battery energy storage systems. Dan?
Hello from my side. Thank you, Dalibor. So let's go a little bit details in all the areas and possibilities of Zenon software. So those of you who don't know yet about us, so we provide HMI SCADA solutions, and within this platform, we also offer many possibilities for analytics, reporting, remote access solutions, IoT options for connectivity, archiving, connecting to superordinate system through our gateways, and our customers are system integrators, utilities, industrial scale users, OEMs, and the areas are, of course, in bulk generation, all industrial applications, critical infrastructure, and many others. So if we take a look a bit, all additional possibilities of Zenon software, so we can help you connect to all your processes, so to your PLCs with our extensive PLC driver library, so we can also seamlessly connect to all your inverters, and different assets. And then on-site, additionally, we can provide some possibilities for additional process logic with our integrated soft PLC, and then connect also with which you can normalize your data. So add calculations to add value to your raw data from your processes. And then we can offer you many possibilities to connect to your third-party systems and additional superordinate systems. So with our process gateways, you can connect to your MES systems, ERP systems in the industry, in energy industry. We can connect to your BMS systems with our process gateway 6871.4. And with Zenon IoT services, you can connect to your distributed, you can put into the network your distributed power plants and also access to other third-party systems. So if we could take a look a bit each of these areas in more detail. So in solar PV generation, you can use it for a plant dashboard, for solar heat map, detailed inverter monitoring, alarming, event logging, and so on. With your battery energy storage systems, again, these dashboards are all pre-prepared templates, which all our partners can use as a starting point to set up their own HMI SCADA systems. So they are free of charge, and we have a team who is preparing these templates for your SCADA systems so that you never need to start with the blank screen. We have many things prepared, so you can start and be very efficient with your design process. So again, with many different possibilities of connecting to your hardware, we can offer very, very flexible software in the middle. If I return a bit to the topic on the previous slide, so within the different industries, this integration layer, so we do not offer only solutions for setting up your HMI and SCADA system. So we are also, in a way, an integration layer in different industries. It's called either plant information manager, plant information layer, or automation integration layer. So where you can, at the bottom, connect to your processes and translate this data to, for example, one specific protocol to exchange data with superordinate systems. So with wind power, similar role for Zenon. So we can have fleet supervision, plant dashboard, monitoring of your turbines, and so on. With the network control centers, you can create this distributed management system for your water supply, gas supply, and also with these integrated solutions, a medium and low voltage grid. So we have use case for smaller towns, also as a DMS system. And of course, integrated geographic information system. So many possibilities for good situational awareness of your processes. In hydropower plants, again, you can set up your fleet management. Also, plant history and reporting are also very much needed in your hydropower plants, additionally with all previously mentioned solutions. And today, of course, many necessities for integrating e-mobility solutions with our OCPP driver, we can connect a nice SCADA system for your fleet of, let's say, electrical vehicles. Also, with this topic, we will expand with our next presenter. So, energy management control rooms in industrial applications. So you can set up a nice control system and system for analytics, reporting, and dashboarding. So a really nice control and automation solutions. With all these areas, we have many success stories described on our webpage, so I invite you to take a look at them. And now I think it's time to present our next speaker, Mr. Tomasz from Poland, from Elsta, who will present us industrial energy management system case from elemental strategical metal plant in Poland. So please, Tomasz, I invite you to take over and present us this really nice use case.
Yes, hello, thanks for inviting me. My name is Tomasz and I'm Specialized Project Director in Elsta, responsible mainly for the engineering teams. At the beginning, I will quickly go through the company profile, so just you can understand who we are and what we were able to achieve so far. And then I will focus on the topic which we want to discuss. So EMS and the optimization of the energy. Firstly, Elsta is similar as Copa Data, is working in the industrial sector, mostly for the energy, but not limited to. We are long on the market, over 36 years, and we are providing comprehensive services for our clients. These solutions are tailored to each project, and like I would say, the experience and flexibility are key factors why we are being chosen. So like I said, 36 years, over 30 countries where we sell to, and around 30 or 300 employees all over the world working. Most of them are in Poland, but we are present in the European Union. Our offer is complex, like I said, from design through production, automation, commissioning, maintenance, and installations across the Europe. So we're able to do the turnkey projects. Quickly about the production, which is one of the main factors, and we are able to produce a lot of electrical equipment, such as LV switchgear based on Siemens licenses, Cubic licenses. We are able to provide you with MV switchgear, from simple ones to really complex 50 k amps, and they are alongside with the electrical drawings, with the parameterization of the protection relays, so fully engineered, commissioned solutions. E-houses is something which is quite popular nowadays and is also provided by us. These are the steel electrical rooms which are fit in with our equipment, not only our equipment, but it's mostly our equipment. So they are fully designed per project, specified according to the specification provided by the client. Then smaller solution related to e-houses, it's transformer station. This I think everyone is aware of. There are standard solutions, and we are able to produce such units up to 10 megavolt amps. And more related to the subject, also related with e-houses, it's battery storage, which was a few years ago designed by Elsta, and it's being produced by us. And it's getting more and more attention since the market is shifting and regulations are taking place. And this is our solution. Actually, we have two options for our clients. One is called Plus, and the other is Standard. Standard is more what is already on the market, where everything is in one container, which is more or less standard container used in transportation, but it's fitted to the users. And the Plus is more industry related unit with segregation, gas suppressions, withdrawable cassettes. So all practices which are common in the industry, we transported to this solution. And inside we also are putting our own active filters to optimize the electrical power in the network. We are also putting our own frequency inverters for these storage systems. So this solution is, let's say, our design, our manufacturing, and unfortunately it was not used on this project, which I will mention, but this project which was covered last year in Elementary Strategic Metals Zawiercie in Poland, was done mainly in part of integration of all of these components, which I mentioned before. So medium voltage switchgear, battery, energy storage, SCADA, PLCs, all of this was integrated by us, and over everything the EMS, so energy management systems, is taking charge. This solution was based on Copa Data Zenon because of its flexibility and mentioned templates which we could use because the schedule was quite tight. So we had to have a reliable and adjustable solution. The company, Elemental Strategic Metals, it's mainly focusing on recovery of the rare materials, and it's using electric arc flash boilers, so they are quite low demanding. That's why the values here for the PV, which I present you, like 12 mega on 16-17 acres east-west, which is suited to the needs, also enabled optimization of the field because north-south was not really optimal. So these values, are quite large. At the moment, I think it's the largest energy storage solution in Poland, which is up and running. Regarding the energy storage, we have 7 containers. They are in 3 groups, but each container has 2 mega. In total, there are 35 inverters, and like I said, 3 transformer stations. And main function of this EMS, which we wanted to integrate, was to communicate everything what is possible, to gather a lot of data as much as possible, exchange some of this information with energy provider, provide the customer monitoring and control, provide the proper data analysis and customer reports, and overall to optimize the consumption and enable energy management costs for the client. Here I've put 2, let's say, cases which we can observe in such system. Of course, there are many variations, but we chose, let's say, almost the best one and the average one. And you can see here you got the average SOC, then you got grid, PV is in gray, and mega energy storage is in blue. You can clearly see that the grid usage is 0. Actually, I've put here that it's real value, it's 300 kilo, because this is something which we calculated based on the class of the devices, that this is the acceptable, and it was also confirmed with the grid operator that this value, if it's not exceeded, will be treated as 0. regarding the overall capacity, it's really small value. It may seem high, but it's really small when you think about megawatts in few seconds. So in the sunny day, we can see that the grid usage is almost zero. Then we can see that during the night, because it starts on midnight, during the night, energy storage takes over whole load. In the morning, this energy storage is being charged by the, let's say, overflow in the from PV, and the PV is taking over to take care about the side load. Later, when we see that the energy storage is fully charged, only PV is producing as much as it's needed for site usage. And later on, when the sun is off, PV is slowing down, and we can see that the energy storage is taking over. So it's perfect solution. You can see that the parameters of the equipment were adjusted really well, but there is also place to optimization, but I will say about this later. Second screen, which we can see, is during the cloudy day. And here the situation is not so beautiful as on the previous slide, but we can also see that during night we are taking the load from the factory, but in the morning there is not enough sun to charge our storage, so site is working from PV. Some excess is being transported to the energy storage, but it's not enough. Only during the peak hours, so during noon, we're able to charge, but also not fully the storage. So in the meantime, there is small grid usage, but it's limited to less than an hour. Then, similar as in the previous case, sun is going down and the energy storage is taking over, but we can also see here that there was not enough. So we had energy storage load up to 85%, I would say, and there was not enough power coming from the PV, and there was peak in the load, which was shaved, as we say, by the energy storage. So you can see that here there was bigger demand, but bigger demand on load, low production of PV. So the energy system had to come with help in order to not use the grid. A part of this automation part that it's working in automation mode, we also introduce for the client the few functionalities which are a bit, let's say, manual for practicing for maintenance. So there is weekly schedules for the operators, which can be programmed by each hour and what should be done. So this can be done for, like we said, for maintenance or for testing purposes to gather some more data. We also introduced full monitoring of the medium voltage switchgear using the Zenon tools with automatic coloring, with pop-ups where we can gather all information, check the status, faults of every equipment, control them. So this is also one of the screens. We also introduced manual control of the sections of energy storage and of the PV. So you can see here in the frames which I marked that we can manually switch off part of the PV. We can also switch off some of the magazines if needed. Of course, if we lose this equipment communication or there's some issues, failure, it will automatically switch off. But if we want to make sure that there's, for example, maintenance, we can switch it off also here, so the system will not make any mistake. The general overview, it's also presented. As you can see, you got the charging of the storage flowing through the process. these graphs, which are updated I think every minute. As you can see, we also introduced 10 and 90% limits to keep the batteries, let's say, in the optimal condition, so they can last more charges. We also are monitoring full PV. We are checking how they are doing, not only in case of the power, but there are also the data taken over for the faults, for predictions. We are calculating what may happen in the system based on these readings. There are some data collected from the sensors, also put it in the field near the PV. We are also monitoring all conditions and all signals from the energy banks. Like I told you, there are 7 of them, but they are grouped in 3. So we are taking all the information available from the smart loggers, and we are also providing to the customer detailed analysis and reporting. And some of these reports are really custom made. Some of them we are able to use templates from Zenon, especially for alarms and graphs. But we are able to archive everything on the server, and it's a lot of data. We can export this to spreadsheets, generate the reports whenever we want. Sorry, oops. And all of this is already done. And next improvements which we could do, but they are, well, some of these things are already working, but we need to gather more data to have better understanding of each site, as each site is different. Then we are linked also with the existing SCADA control system. And therefore, we are able to exchange some data, collect some information regarding the plant load. But again, this is being changed because the site is working on 24-hour basis. So we need to gather data at least from 1 year to understand everything. So then this demand peak prediction will be even better. Expense monitoring also is related because we are getting data from the meters and from the prices. So everything can be optimized if the enough data is, let's say, gathered. And the last thing which can be done at the moment is the next day market, but generally it's being changed in Poland currently, and it's being developed. So in order to maximize these profits, there will be possibility to, let's say, play on the market on hourly basis or dynamically. At the moment, we are doing it day by day. And coming to the conclusions, which from this project, the savings. So the topic of our discussion, some of them are obvious. And like I said, PV production for the plant needs, everyone knows that this is helping. Even prosumers have this option. So this is one of the savings. PV production for charging battery storage, because we can use this energy later when the energy is needed. We can have different scenarios, and this is regulated by the energy operator, but we can play with this energy which we store, which is also quite obvious. Then discharging this energy based on dynamic prices. This is something which is ongoing. It also gives you the flexibility to charge for, let's say, 0 and sell for more, or use this energy where you have the peak or you expect the peak because you will be starting the plant. So these are the conditions which need to be valued amongst the site efficiency and site and economical value. But I would say the outcome which gives the greatest savings is actually reactive power compensation, which when we've checked, we cannot give exact numbers because these are the constitute trace excess of elemental strategic metals, but comparing all these obvious savings which were planned, the biggest savings from this project actually are from compensation of the reactive power. And this may be surprising for some of them, for some of you listeners, but actually this is the factor which is not always taken into account when you are calculating return on investment. And here I know that this return on investment is quite well planned, and it's even better than expected. And the client is also thinking about extending the capacity of the energy storage, just because they already see the benefits from this solution. So that's briefly everything from my side. If there is something else, I'll be open for the questions.
Thank you, Tomasz, for this amazing story. I'm sure it was really interesting for all our participants to hear. Let's move on to Q&A session. Let me check the Q&A. There are some questions already. You can post also now questions for all of us if there is something that we missed to mention. Let's start with how much data is being gathered daily and how many signals are being shared. This is regarding the project. So Tomasz, answer.
Well,
so how much data is being gathered and how many signals are shared?
I would say that on average, we got around 1 gigabyte of data every day being collected for analyzing purposes. And regarding signals, I think it was because there are two types of signals, one which we are using, gathering, one we are sharing across the applications, and the other ones are where we are sending them to the grid operators. So grid operator, I would say it's like 150, 60 signals, something like this, less than 200 for sure. For sharing inside, it's I think below 2000, but around 2100, 600, I think it was at the beginning. Then we added a little bit more. And regarding the signals which we collect in total, I would need to check because it's really a lot what we are collecting just to have the informations. But that's the general.
Okay, yeah, I think it's a good answer. There is another one. Which communication protocols are you using? Probably also in the project, I can say that Zenon provides the system integrators and the end customers the opportunity to use more than 300 communication protocols, drivers, gateways, different one. But maybe Tomasz, which communication protocols are used in this project?
In this project, we got actually few protocols because, some devices which we had to integrate. Well, we had to integrate a lot of devices, so we are using the Modbus, Profinet. There is ES 103 and 4. So it depends on which level different type of communication protocol is being used. But generally, all of this is again possible due to the Zenon, which is enabling all this communication. It's just a matter of buying proper drivers. And also we used a few equipment which are like RTU, PLC, which also support the solutions. They enable us to interact in proper timely manner depending on on the case, yeah, because sometimes we need to react really quickly. Sometimes we have time for analysis and putting back the solution within a few seconds, and it's not a problem.
Yeah, the continuation of this question is, are those communication protocols encrypted in some way? So regarding the cybersecurity and the communication, the safety of the communication, do you know something about that?
Regarding the cybersecurity, this we introduced this basic, I would say basic standards, so hardening of the ports and so on. But the general infrastructure was created under the Elemental. So we make sure that our solutions are certified. So each device, like devices and like Zenon, each solution is fully certified. But like whole network to which this system is created was already existing, and we introduced this system to the existing network. So overall security is managed by the IT department of Elemental, and over there they have all settled. But we make sure that the parts which we introduced are fulfilling all the needs for the cybersecurity regarding the protocols, regarding the certifications, and the general philosophy.
Dalibor, if I can just add one comment. So basically, in such industrial use cases, Zenon is also in a way a protocol translation, right? So how many protocols did Tomasz mention? And then usually within an industrial use case, you have one third-party system above us, right, where we share all this collected data through, for example, only one protocol, right? And also with Zenon, if the other system enables encryption, basically for superordinate systems like Process Gateway 104, this is a checkbox for us. We can offer encryption through all communication.
Yeah. Generally, here we also concentrated everything in so-called RTU. So all of these different data protocols are in the RTU, and then with the main system, we are mostly IEC 104. This is the, let's say, this main road. But generally, there is Modbus TCP, Modbus RTU, Profinet, ES 103. So a lot of them.
Yeah, thanks. There is a big thank you for explanation from the participant who asked those questions. So there is one request for quotation. We will share this with Tomasz afterwards, so we'll not talk about it now. If there are other requests for quotations, feel free to send it to us. There is another interesting, what are the most important KPIs in your opinion for battery storage systems, like efficiency, losses, degradation?
Well, this is good question actually, because we are discussing it internally with the clients. And however you think about it, and how many options you think about the KPIs efficiency, at the end, it's all about the costs. But from what we've seen, this type of costs may differ. Well, it's maybe sometimes not obvious, but even if we say that we have to keep the energy, even though it will be profitable to sell it, but we know that there will be huge load demand, or we'll need to start up the plant, and this will provide the facility up and running. Then the cost of not running the facility will extend the cost of actually selling this energy to someone else. Yeah. So we've been through many cases, and actually you need to look at each site, each project separately, define with the client what are their key factors regarding the stoppage, the failures, what kind of failures can it be, about the symmetration, like here the compensation. So if you get all of this in place, then you can put some key factors of them. But at the end, all of this is costs, yeah. But some of them are really obvious. Some of them are hidden behind some technical features. But at the end of the day, the main KPI is to optimize the overall cost, but we need to make sure that it's well calculated, and then during the execution we need to verify that this let's say coefficients are properly adjusted, because we don't want to have cases where we put too much value to something which may happen once a year. So it's all about statistics, about
Dalibor, I think
Yeah,
we lost our guest speaker. But anyway, I think we are at the end anyway.
Yeah, definitely. Yeah, we can maybe wait for another second if he joins back, but probably internet connection or.
Tomasz mentioned he had some problems at the beginning, so we apologize for this glitch. But anyway, we are open to all additional questions to you online. So Dalibor, I think you can share your next slides where they can find our email addresses.
Yeah, I just wanted to mention that everything here is being recorded, so everything will be available in our YouTube channel or our previous webinars. Also tutorial videos, tips and tricks, use cases are also in our YouTube channel. You have a link here. You can scan the QR code now if you want. Just subscribe and you will get the updates. So all other questions we can answer afterwards. Oh, Tomasz is back. But
yes, sorry, I lost connection, so technical issue.
Yeah, no problem. We moved forward, so since the time is it's like 45 minutes is the beginning, so we can maybe close it for now. There are two more questions that we can answer really afterwards. So all the questions will be answered afterwards directly. We have your all contacts, so stay relaxed. You will get the answer pretty soon. So as I mentioned, our YouTube channel, everything will be shared there too. You can contact us all, including Elsta, of course, for quotations or whatever you need from us. There are our emails. You can write to us. You have our direct contacts here. So thank you for joining us today. It was really a pleasure to see this really nice reference from Poland. It's really well structured and something that we'll definitely need in our market pretty soon. So thank you, and see you in some of our next webinars. Have a nice day.
Thank you. Bye.
Thank you. Bye. Have a nice day.